The activated sludge process is a process for treating sewage and industrial wastewaters using air and a biological flock composed of bacteria and protozoa. In a sewage or industrial wastewater treatment plant, the activated sludge process is a biological process that can be used for one or several of the following purposes: oxidizing carbonaceous biological matter, oxidizing nitrogenous matter, mainly ammonium and nitrogen in biological matter, removing nutrients, nitrogen and phosphorus. The general arrangement of an activated sludge process for removing carbonaceous pollution includes the following items. Aeration tank where air or oxygen is injected in the mixed liquor. Settling tank, usually referred to as final clarifier or secondary settling tank, to allow the biological flocks, the sludge blanket, to settle, thus separating the biological sludge from the clear treated water. Treatment of nitrogenous matter or phosphate involves additional steps where the mixed liquor is left in anoxic condition, meaning that there is no residual dissolved oxygen. The process involves air or oxygen being introduced into a mixture of screened and primary treated sewage or industrial wastewater combined with organisms to develop a biological flock which reduces the organic content of the sewage. This material, which in healthy sludge is a brown flock, is largely composed of saprotrophic bacteria, but also has an important protozoan flora component mainly composed of Amoebae, Spirotrex, Paratrix including Vorticelids, and a range of other filter-feeding species. Other important constituents include motile and sedentary rotifers. In poorly managed activated sludge, a range of mucilaginous filamentous bacteria can develop including Sphaerotilus natans, which produces a sludge that is difficult to settle and can result in the sludge blanket decanting over the weirs in the settlement tank to severely contaminate the final effluent quality. This material is often described as sewage fungus, but true fungal communities are relatively uncommon. The combination of wastewater and biological mass is commonly known as mixed liquor. In all activated sludge plants, once the wastewater has received sufficient treatment, excess mixed liquor is discharged into settling tanks, and the treated supernatant is run off to undergo further treatment before discharge. Part of the settled material, the sludge, is returned to the head of the aeration system to reseed the new wastewater entering the tank. This fraction of the flock is called return activated sludge (RAS). The space required for a sewage treatment plant can be reduced by using a membrane bioreactor to remove some wastewater from the mixed liquor prior to treatment. This results in a more concentrated waste product that can then be treated using the activated sludge process. Many sewage treatment plants use axial flow pumps to transfer nitrified mixed liquor from the aeration zone to the anoxic zone for denitrification. These pumps are often referred to as internal mixed liquor recycle pumps, (IML pumps). The raw sewage, the RAS, and the nitrified mixed liquor are mixed by submersible mixers in the anoxic zones in order to achieve denitrification. Activated sludge is also the name given to the active biological material produced by activated sludge plants. Excess sludge is called surplus activated sludge or waste activated sludge and is removed from the treatment process to keep the ratio of biomass to food supplied in the wastewater in balance. This sewage sludge is usually mixed with primary sludge from the primary clarifiers and undergoes further sludge treatment, for example by anaerobic digestion, followed by thickening, dewatering, composting and land application. The amount of sewage sludge produced from the activated sludge process is directly proportional to the amount of wastewater treated. The total sludge production consists of the sum of primary sludge from the primary sedimentation tanks as well as waste activated sludge from the bioreactors. The activated sludge process produces about 70-100 kg/ml of waste activated sludge, that is kilograms of dry solids produced per ml of wastewater treated. 1 megaliter (ml) is 103 meters, 3. A value of 80 kg/ml is regarded as being typical. In addition, about 110-170 kg/ml of primary sludge is produced in the primary sedimentation tanks, which most, but not all, of the activated sludge process configurations use. A variant of the activated sludge process is the narrative process, where aerobic granular sludge is developed by applying specific process conditions that favor slow-growing organisms.